Hello everyone, and welcome to the Advanced Sets lecture. So in this lecture we'll be learning about lots of different methods for sets that you may not have seen yet, and we'll start by going over the basic ones you already know and then dive a little deeper. So as always, there's a Jupyter notebook that has everything we're going to go over as well as many examples, so you can go ahead and check that out. So let's go ahead and look at advanced sets first. So in this lecture we'll start with some of the basics. So we'll start with building our set, and then how do we add things to a set? Well, we just use the add method. So here I'm going to add 1 to my set, and I'll add 2. And remember, a set won't take any duplicate items. It only presents them 1. That's what makes it a set. So if I were to try to add 2 again, I only get 1, 2. So we know we can add with add. So we can also clear or remove all the elements from the set using the clear method. And that looks like this. So if I check my set, now it's empty. So another interesting method that you may not have seen yet is copy, which returns a copy of the set. So to show you that example, here I have set 1, 2, 3, and I'm going to set a variable called sc to a copy of that. And now sc is 1, 2, 3. So note, it is a copy, so changes to the original won't affect the copy. So if I say s.add, here is my original, there's the copy. Okay, so what about a couple more methods that you haven't seen yet, such as the difference method? So difference method is a super useful method, and it returns the difference of 2 or more sets. So the syntax looks like this. You provide your set, called difference, and then the set you want to check the difference between. So the only difference between S and SC is this 4 elements. So it returns the elements that are different. And so another really interesting related method is difference update. And what difference update does is the method returns set 1 after removing elements from set 2 if you have this sort of format here. So I just copied and pasted this from the Jupyter notebook. So the syntax looks like this. You have set 1, you call for the difference underscore update with set 2, and the method returns set 1 after removing all the elements that were found in set 2. So I'll show you an example of what this looks like. I'll create a new set, S1, create another new set, S2. This will have 1, 4, 5. And now, if I call S1 difference updates with S2, and then I'm going to call S1 again. So note what I get back, 2, 3. So the matching elements between S1 and S2 was the 1 element here, number 1. And what difference update did was it returned the first set after removing all the elements found in the second one, in which case it would have been 1, so you get back 2, 3. Another interesting method is the discard method, and it removes an element from a set if it's a member. So if the element's not a member, it doesn't do anything. So I'll show you what I mean by that. So let's go ahead and check out this set. We have S, which is 1, 2, 3, 4, and I can discard, let's say I discard the 2 elements, and if it's in the set, it'll get rid of it. If it's not in the set, say 12, nothing happens. So you don't get an error if it's not in the set, something to keep in mind. Okay, now let's go ahead and learn about the intersection method, another very useful method for sets. What it does, it returns the intersection of 2 or more sets as a new set. And the intersection is just the elements that are common to all the sets. So let's go ahead and redefine S1 and S2. So 1, 2, 3, 4, and then S2 is going to be equal to 1, 2, 4. Okay, and what I'm going to do is check for the intersection of the 2. And there's an intersection update method, which we'll learn about in just a second. So S1 and S2, the elements that are common to both of the sets is 1 and 2. All right, so intersection update will update a set with the intersection of itself and another. So if I try this method on S1, notice S1 is 1, 2, 3, but if I say S1 intersection update with S2, it will actually update set 1 to be equal to the intersection of set 1 with S2. So S1 was 1, 2, 3, and now it's going to be with intersection update equal to, that intersection. So now if I check S1, it's 1, 2. So let me just break that down because I know it's a lot of 1s and 2s that I'm saying. So originally set 1 was the numbers 1, 2, 3, and set 2 was the numbers 1, 2, 4. So the intersection, or the elements that are in common between them, are the numbers 1 and 2. That's their intersection. And with intersection update, it basically makes the first set equal to that intersection. So if I check it again here after the update, I just get 1, 2 back. Okay. So now we're going to check a method called isThisJoint. So I'm going to create a few sets to show you how it works. So I'm going to create 3 sets, S1, which is 1, 2. I'll create S2, which is 1, 2, 4. And let's say S3 is equal to just 5. Okay. So this method was going to return true if the 2 sets have a null intersection. So for instance, S1 isThisJoint S2 is going to return false, which makes sense because they do have an intersection. They have the elements number 1 and number 2 are in common between the first 2 sets. Now, for instance, S1 and S3 here don't have any things in common, so they don't have an intersection, which means they have a null intersection. So if I was to say S1 isThisJoint with S3, I should get true because they do have a null intersection. Another interesting method is isSubset, and the method reports whether another set contains this set. So if we look at what S1 equals, it's 1, 2. If we look at what S2 equals, it's 1, 2, 4. So you notice S1 is a subset of S2. And we can check that by asking isSubset with the isSubset method, and this will return true. And then basically the reverse of that is isSuperset. So the method reports whether the set contains another set. So I can reverse this and say is S2 is supersets of S1, and that's also true. So they're just the inverse of each other. All right, now we're going to learn about a method called symmetric difference, and there's also a symmetric update to go along with it. So symmetric difference will return the symmetric difference of 2 sets, and what that is, it's all the elements that are exactly in one of the sets. So you can think of this as basically the opposite of the intersection. So if we have S1, that's 1, 2, and we have S2, that's 1, 2, 4, then the elements that are only in one of the sets is that 4 element, right? So I can check for the symmetric difference, and that will return 4, since that's the element that's in exactly one of the sets. Okay, and then there's also a update to go along with that as well if you wanted to change S1 into just the symmetric difference, or 4. Moving along, I will now go over union. So the union method returns a union of 2 sets, and that's all elements that are in either set. And that will be here in this case 1, 2, 4, because 1, 2, and 4 are in either set. Okay, and last but not least, we'll go over the update method, and it updates a set with the union of itself and others. So that means if I said S1.update S2, if we check S1, it's now the exact same result as if we asked the union on itself and another one, S2. Okay, so you should have at least now a complete awareness of all the methods available to you for a set object type. I personally think the data structure is underutilized by beginners, so try to keep it in mind when you're trying to do comparisons or looking for unique values. The data structure itself is extremely useful. And let's just take a brief overview of everything we learned as far as methods. So we know about the add method, which adds elements to a set, the clear method, which removes all elements from a set, the copy method returns the copy of the set, the difference returns the difference of two or more sets, has that syntax. Remember, there's a lot of update methods which will change the first set in that method. The discard, which removes an element from a set if it's a member. If the element's not a member, it doesn't do anything, so it won't throw up an error. Intersection returns the intersection of two or more sets, which is just the elements that are in common to all of sets. Also has an update method. Is this joint returns true if they have a null intersection, so they don't share any elements. Is subset reports whether another set contains that set. Is superset the inverse of that. Symmetric difference will return all elements that are in exactly only one of the sets, and then you can update it as well. Union returns a union of two sets, all elements that are in either set, and then update will update a set with the union of itself and whatever others you pass in as arguments. Okay, so that's it for the advanced sets lecture. Thank you and good job. I'll see you at the next lecture.